right, so we want to talk a little bit about logical arguments. And first, probably start with just an example. In logic, arguments take this format. You may have heard this one before. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. This is typically the way we'll arrange it. We've got three statements there, but obviously we have one of the statements is our conclusion. And then, I guess you might say, the other two parts are the first parts, which are called the premises. Premise 1 and premise 2. Yeah. And so, in a good argument, good logical argument, your premises will then lead you to a valid conclusion, which I think most of us would follow that one pretty well. But that's what we're talking about, the types of things we're talking about. Here's my premises, two premises. Most of the ones we'll do would be two, but if you get more into it, heavily involved into it, you'd have more than two premises maybe. But this is what ours will look like, or something very similar. Well, you have a couple premises and then the conclusion. Now, the key to arguments is to have a good argument, a valid argument. is the way we'll phrase it. We'll be looking for those for the other two, but validity of an argument is something that's important, obviously, in logic. And here's how that works. An argument is valid when all the premises are true, the conclusion can only be true. If, when all premises are true, the conclusion can only be true. Make sense? Because you're trying to put together something that, these two or whatever the premises are, you're saying, well, these two lead me to this one. So if these are true, then this one has to be true. That's what we're saying. Now, what we might spelled Socrates wrong there, didn't I? What we also might note there is, if one of these premises at some situation is not true, well, does it really matter what the conclusion is? No. We're just saying if these are true, then this one's true. If this one's false and this one's false in a particular case, then it doesn't really matter what happens to the conclusion. So we'll speak to that more in just a second. But we also should point out, be able to recognize an invalid argument, which also known as a fallacy. An argument is invalid and I'm reading back through an argument. I forgot some words there, didn't I? So the first one, the valid argument, an argument is valid. I forgot that part. So part two here, an argument is invalid or a fallacy if the conclusion can be true when all premises are true. That would make it invalid. So you got these two are true, but then the conclusion can be false. If that happens, then your arguments run into a bit of a problem. Okay? So that's what we're going to focus on for a moment or two here. Valid and invalid. A couple ways we're going to do this. Well, they're both related, but kind of two techniques here that we'll utilize. Guess what one of them is? Truth tables. We'll use some truth tables, and then we'll talk about the other in a moment. Okay? So first of all, let's remembering these two definitions, if you will. Determining validity by truth table. Kind of where you have to start, and then we'll play off these in just a second. Okay, got all this? All right, determine validity of an argument by truth table. All right, let's talk about an argument form in symbols. Let's say I've got P arrow Q is my first premise. The second premise is P, and the conclusion, well, it's going to be Q. Pretty basic argument form. But, yeah, what I want to do here is determine if this is valid by truth table. This is how we do that if that's our given charge or the problem. This is how we do that. Step one. We're doing a truth table, so that's step one. Do a truth table for each part. And we can do it all together here. We got P's and Q's, right? So we need a place for P arrow Q, my first premise. Then I need the second premise, P, and then the conclusion, Q at the end. So we need a truth table. We'll just do all together one. Okay? All right, so we got true, 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 false, false, true, false, false. And then just put the truth values for each one of those. That was pretty straightforward, so I'm not even going to write the component, but you can if you want to. But it'll be true arrow true, which is true. True arrow false, which is false. F arrow true, which is true. And F arrow F, which is true. That'll be the truth values of the first premise. And then the other two are real easy. This one I just have to copy the P column, which is true, true, false, false. And then this one I have to copy the Q column, which is true, false, true, false. Step one down. 3 steps. Step 2. Well, remember back on the definition of valid or invalid arguments is the definition said if when all the premises are true. So step 2 is it doesn't matter what happens when a premise is false, so I'm going to mark out any line that has a false premise. Now, it's not saying mark out any line that has a false in it. It's saying mark out any line that has a false premise. Which are the premises here? Which 2 columns? Which columns? Well, the premises are only these 2, right? So my premises are this column and this column. So I'm only looking, on step 2, I'm only looking in those 2 columns. This column and this column. I mark out any line that has a false premise, though, because it doesn't really matter what happens in those cases as far as a valid argument is concerned. So line 1 does not get marked out, obviously, because it has 2 true premises. What about line 2, though? Well, I've got a false premise, don't I? So I mark it out. What about line 3? Mark it or scratch it out, and I scratch out the whole line. Yep, because there's a false premise. And then what about line 4? Yep, it's got a false premise, so it gets marked out too. Okay? So we're down to one line. Well, step 3 then is determine if it's valid now by looking at the conclusion column and the conclusions that are left, and determine if it's valid. A, if there are only true conclusions left, it's valid. The argument's valid. But B, if there is one or more false conclusions left, it's invalid. Because that's the whole deal. I mark off any that has false premises, so those don't matter. Now, what I have left, though, only have both premises true. So if I have something that has a false conclusion left, then that says I've got 2 true premises and the conclusion's false. Well, that's invalid. That's an invalid argument. But in this case, that doesn't happen, though, does it? What do I have left as far as conclusions go? This is always looking at the last. Whatever's left here in the conclusion column, that's what I focus on now. What do I have left in the conclusion column? I only have true left. I marked off false, true, and false, so those I'm ignoring now. I just ignore those. Only with what's left conclusion-wise. And we're okay, aren't we? Because there's only trues left. There's only one true left. Okay. There's only one left, and it's true. So what is it? Valid or invalid? It's valid. If you only have a true left, or true, if there's more than one and they're both true or whatever they are, it's valid. Okay, so this one's valid. So only a true left in the conclusion column, so the argument's valid. This argument here we're talking about. It's valid. It's a valid argument for it. Okay? All right. Let's do another one. P arrow Q starts the same. Then we're going to go not P, conclusion not Q. Same instructions though. Let's determine if that one's valid by using our little truth tables. Do what?
You're just doing a random problem. When you have them in the book, will they be just random? I mean,
yeah.
Just have them like that.
Yes. This will be exactly like they're stated in the book here. Here's your possible argument. Is it valid, though? Well, let's see. Let's test this one out. So what's step 1? Just do your truth tables. P's and Q's. Got P arrow Q. First premise. Not P is the second premise. Conclusion is not Q. Same 4 lines. True, 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 false, false, true, false, false. Arrow, first of all, those together. True arrow true is true. True arrow false is false. False arrow true, though, is true. False arrow false is true. The next premise is not P. It's just the opposite of the P column, so that would be false, false, true, true. And then not Q is opposite of the Q column, so that would be false, true, false, true. Step 1. What's step 2? Step 2 was mark out any line that has what? False premise. So again, I'm looking only at the premises here, which are the middle two. Forget the others for right now. So mark out any that has a false premise. Does line 1 have a false premise? Yes, it does, right there. Mark it out. Line 2 have a false premise? Actually, it has 2 false premises, so it's, you don't have to mark it out twice, but it is marked out. What about line 3? They're both true, so it's not marked out. Line 4 has both true premises, so it's not marked out. So that's step number 2. Step 3 then. Step 3, we look at the conclusions left. What do you see? There's a false premise left, isn't there? That's bad. There is a true premise left, but there's a false premise left. And it's, so to speak, overrides the whole deal. So what do we got? Is this valid? It's invalid, yeah. If one of the lines you have left has a false conclusion left, it's invalid. The argument is invalid. The original argument there, it's invalid. Okay? That's how it works. All right, let me do one other if there's no other problems or concerns there. Make sense? Okay? Determine validity of this one by R. They won't all be P or Q. Let's do a P or Q. P or Q is the first premise, not Q is the second premise, and the conclusion is P. Again, instructions are use the truth table. We'll do it maybe a little different way here in just a second, but for right now, all we have at our disposal is the truth table. Make a couple quick points here. Got P's and Q's, so it's the same over here. True, 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 false, false, true, false, false. And we got P or Q, not Q, P. Okay. All right. Let's say I go ahead and do this. P is true, true, false, false, and Q is true, then false, then true, then false. Let's go ahead and write that under each one of those. Then we got to OR them together. So true or true is true, true or false. It's OR, so it's true, isn't it? OR is one of them's true is true. False or true is true because one of them's true, and false or false is false. I do that because, well, I'll make a point here in just a second. Then I do not Q is false, true, false, true, and then P is true, true, false, false. Okay, that's step 1. Step 2 is mark out any line that has a false premise. Okay, so yeah, line 1 I mark out because I'm looking at the premises, which are the top 2, these 2. Only focus on those 2. All right, got false premise there, so it's out. What about line 2? Does it need to go? Line 2 stays, doesn't it? I'm only looking at this and this. Even though there's that false, this is the only thing I need to focus on, so it stays. There's a false premise, so it goes. There's a false premise, so it goes. So only left with line 2. Which, looking then at the conclusions left, there's only a true left, So what do we got? Valid?
No.
Valid. Okay. So that's truth tables, invalidity.